open. We're really here to brainstorm and see what is possible and to learn ourselves. So any questions? There's a lot. I'm jumping around and showing a lot of different interfaces, but again, remember that some users might only look at the report. They might say, well, I just want the bottom line. What's my project going to cost? The owner says, give me my cost summary, and we give them a report like this. This number is tied, the bottom line number is tied to the, in fact, there's a connectivity week building is going to cost us $68 million. It's tied to those decisions that I'm making, and they're seeing that update as we're making the changes. A lot of other kind of reporting that happens here, but any questions? Yes? Right, the question is how would you create different versions and archive different design options and then compare between them, right? Yeah, you would, you could either do it directly like I did here. I might say, well, here's version 1 and here's version 2. In fact, these were the same buildings. Remember, I pulled the data from one to the next. So I could go into this and say, I made this connectivity week building. It could be, I'm only showing you one scheme out of hundreds or thousands. So you can create, you could duplicate the whole thing and create another version and start comparing against it. Or I did it directly in here. So if I wanted to compare this building to, compare it to Wing C of the same project. So I know I'm in this project, I'm going to compare it to the L'Enfant Plaza study area, and there was one called Wing C, which we duplicated, and I want to compare the floor areas, and I'll add it to the list. Now, if I then create a report from this, actually, let's look at the report real quickly. This does a, like when you're shopping for cars, it does a side-by-side comparison saying, here's your current building, and here's the one that your first version. They're going to be exactly this. Actually, no, we changed it a little bit. Remember, I stretched one of the, actually it's catching that already. I moved one of the offices, so it's saying you've made this office 34% bigger. So it's a color coding a delta comparison between those two things on the first floor. And if I go to the first floor here, in fact, and say I want to do a floor plan view of that and color code it, I could do the same thing and say I want to do a comparison. Instead of temperatures, I want to see a building comparison. And show me, there's that room that I made bigger. So this is 20% larger than what the first scheme was. And the same way here, if I were to stretch this and make this smaller, in fact I have to break the rule. If I break the rule and say I'm going to break the square footage, make this smaller and make this one much bigger, and save that, it updates in real time. It's constantly comparing to the first scheme. So this one's red, that one's green. So it gives you a quick view of what decisions you're making. Here we're just looking at areas, but it could be really anything. It could be, well, I want to compare it to the assumptions of, you know, what's going to be the temperature in that room versus what it's right now. It's really kind of endless at that. And it also has the ability to even create what we call, I showed bits of that, but to show an adjacency saying this room needs to be near these other rooms, an adjacency requirement, which could also come in from an Excel file, or you could start just doing pull downs and say this room has a relationship to that other space. So you're creating these business rules that say this person needs to be near that other person. If I look back at the floor plan now and turn on the adjacencies, it's going to draw the version of that. Let's see. Oops, did I not save it? I think I did that too quick. There it goes. Okay. So this, I just did it randomly here, but remember it's like rubber band lines saying this space needs to be near these other ones. So here's the resolution. Client says these spaces need to be near each other. And this happens all the time in design projects. Somebody forgets that the space is over here, needs to be over here, and you go on for, even if you go on for an hour, it's a problem, but sometimes it goes on for weeks, and you forget that relationship. In a typical project, like even on a 500,000 square foot building working with DHS, there's 2.8 million points of data about relationships, about people, about equipment, about things, and all of that is a moving target. Clients constantly changing their mind, day by day by day. So what we're doing for owners is we're creating like this and giving them a real-time submittal. Instead of submitting a PDF file and saying, here's what you're asking to happen, we put it in the database and we hand them access to that database and they can continue to do what-ifs until the time is ready to go. So it's like just-in-time design. You push the button and you send it to the architectural team. They start working with it, and client is still making design changes. So you can start comparing. That's in the design process. Now imagine when that gets done into construction. Now you're managing the building, you're comparing against, so what were the assumptions that we made to make this building LEED green, or what type of energy use assumptions we have. You're starting to compare it to those assumptions, because those typically get lost. As soon as the project's done, all of that engineering and that work that went into design is stuck in a report somewhere or a CAD file that nobody knows what the assumptions were. So you redo it again. You're basically learning over for every project, and that's absolutely impossible to think about when you're trying to resolve and have a high-performing building and get energy tied to it. The only real way to do it is to start making these connections right now before they're lost. So a lot of the owners, including GSA that we're working with, they're asking us to come in and capture data that is being lost every day. They're in the middle of a project. They're saying, we know in our current process we're losing data, and this building is going into construction next year, and after all the construction team leaves, we're not going to know what happened. And we're there helping them to pull data into a format like this, and keeping it open so it could be future-proof. So if another system comes along 2 years from now, the data is not stuck in a proprietary format that you basically trap the owner in. You keep it open. And that's a little bit threatening to some groups because it seems like you're losing control, but it actually opens up new opportunities and new businesses that can happen by keeping it open. And the owner keeps coming back to you. So that's kind of our business model. And we're very open about what we do. We like to share our information. We like to share our knowledge because we can't do it all ourselves. And some people ask us why we do that, but we feel that that's brought us further ahead than trying to hide things and saying, well, this is all ours. It can't be done all by ourselves. Any other questions? I know some people came in late, and if you have any questions, you can come up front and I'll kind of start from the beginning again, or we can have kind of a discussion if you'd like. We're showing real-time BIM connected to real-time energy. It's a new way of looking at how to manage information about plans for a building. Typically in a project, if you're looking at energy data sitting on top of a floor plan looks like it's static, but really it's changing constantly. Floor plans change, buildings move day by day. So imagine if you had an owner that allows you to document their existing buildings and save it as a PDF file or a plan file. As soon as you finish the documentation, the next day somebody's doing a renovation. Therefore, the underlying data is no longer valid. Our goal is how close to real time can we get to manage information about a building and have it in a web-based, it's a cloud-based application. This is a simple floor plan here where we're moving spaces around for early planning, but the same building, it's a cloud-based computing application that and somebody else has access to it, and that's why I can't edit it, but you basically can view and zoom and add data to edit information about a project. And here it's actually pulling in, this is what we're showing here, that we can actually pull in live sensor data, saying here's the temperature of a building, or let's actually look at the temperature, the live temperatures data. So the graphics are being generated from data versus graphics that are saved as static files. So these color codes are coming from sensors in the building saying, here's the temperature of that space. The color coding that says cool, comfortable, whatever is based on engineering assumption that say what is the temperature that room needs to be. The pie chart is saying which rooms have inefficient reheating based on engineering input and assumptions that were made during the design. So a lot of different things happening here, but this is the Onuma system on the web. The data from the sensors is coming from a VROC, it's called VROC server with Mike Lavell's company. That's back here somewhere. There he is. So we're using web services and mashing up data from different sources. So sensor data coming from VROC, Onuma system data coming from a floor plan. If I go up to the site plan level, we have Google Maps coming in from the background, so it's about layering different types of data and having a view. So this is the Google Map view. So the map in the background is not just a graphic that we pasted in. Everything has a latitude and longitude in our world. So if we look at this, we know not only what the longitude and latitude is of that building, but of every element inside the building, down to the individual piece of equipment. It's real time, so as I'm moving things around, other users can actually see what's going on and make decisions. So we're saying, well, we're thinking of placing a building here. What do you think of that option? So to give a quick overview of what conceptually what this is all about is we start by, I'm involved in the Building Smart Alliance Open Standards group, international group, looking at building data. And everything that we do is based on open standards. As much as possible, we're trying to push and pull data with an open standard format, and that goes for connecting to energy data as well. So in a building information model is a three-dimensional model. It's connected to information and data. So as you add a door or a piece of equipment, it has a piece of data associated with it, and you can use that to start doing